So let's try to just go for a final conclusion of spin and angular momentum. Now you can see that all the algebra of angular momentum will be exactly same for the spin, and all the algebra of spin will be exactly same for the angular momentum. So this is a, whenever you have anything in a rotational symmetry, or if you want to work in a spherical polar coordinate, then obviously these are very nice mathematical tool for quantum mechanical understanding. So let us try to go step by step with some very unique problem, and there are very few problem asked into this particular examination. So we will just try to go for just some PYQ. 3 and 4 numbers are there. So I have chosen deliberately such that we can discuss some theory as well as some problems also. So let us go for a very nice problem, and this will be in June 2022. This was one of my very favorite question actually, this has. So this is 2022, that is June 2020. And this question was there, and notation is also very interesting. So sometime you can use the notation of the angular momentum is J also, that is actually total angular momentum. So we will discuss what is total angular momentum mainly in atomic physics. So currently we are just taking the L part separately or independently, S parts independently. Now if L and S will couple, we have J part also, and that J will also fulfill the same algebra what S and L is going to fulfill. So what is this problem? So this problem is that there is a state that is J0 state. So obviously this is for the J square and this is for the Mj. So you can understand the basis actually. The basis is nothing, J and Mj. Okay. And M can be equal to 0. So you can just analogically think this is some L and ML or M is there. So this J vector or J state is going to rotate infinitesimally with epsilon angle in y direction. So what will be the outcome? What will be the final product? So this is our question. So this J is going to rotate in which direction? In y cap direction. So we have to identify what are the final kit. Is that one kit or combination of kit? And this kind of system is always there. So obviously we have to work with some rotational operator. Okay. So what is this rotational operator? So this rotational operator in y angle with some angle theta can be represented by, and this is nothing, exponential minus I theta jy upon hk. So this is my operator. So if this operator will operate on J0, we have to identify what will be the final outcome. And this rotation is actually not a complete theta and the big theta, that is the infinitesimal rotation. So here this theta is nothing but some epsilon, and epsilon tends to 0. So what we have to do, we have to just go for Ry with the epsilon. Now I can use the parameter epsilon, and we will just try to operate on J0. Then we will find, then we are just going to rotate it. So once we are going to rotate it, what we are just getting from here. So what we will take, you will have this particular thing, exponential minus I epsilon jy upon h cat, and that value is equal to what? J0. So this is my rotational vector, and we are rotating something. This is your, and if we have discussed this thing with help of Hamiltonian, hai na? So if you want to measure the energy H and T minus sign, you remember all this thing? Hai na?
Yes.
So we have all this thing. So now, hence it is infinitesimal epsilon. What you can do, we can just go for the Taylor expansion, isn't it? Ja sakte na?
Yes, sir.
Hello? So we can just go for the Taylor expansion. So what is this value? This value is 1 minus I epsilon by h cat, and this value is equal to jy, and you are just going to, and we are just talking about the first order approximation, and that value is j0. So now this thing we have to calculate it. Now I can write jy as what? J plus minus j minus by 2, isn't it?
2i sir.
लिख सकते हैं ना? So we can write this thing as 1 minus I epsilon upon h cat, that will be j plus minus j minus by what? 2i, and this I and I is cancel out, and we have j0 operator. So we are just going to operate on j0. What we will get? We will get, so this is identity matrix, so that will give you some j0. First one will remain same, and second one is epsilon upon 2h cat j plus j0. This is second one, and minus j minus j0, isn't it? So we have to just calculate what will be j plus j0. What is this value? So this value is equal to j0 minus epsilon by 2h cat. I can write epsilon something like this, epsilon by 2h cat. J plus will operate on this j0. What you will get? You will get root under j into j plus 1 h cat. And what will be this cat? This cat is j and 1 cat, isn't it?
Yes sir. Yes sir.
Yes?
Yes sir.
Okay. And the second part is that I am just removing this thing. So what will happen to second part? This minus minus is what? Plus. So j minus will operate on this. What you will get? J into j plus 1 h cat, and you can take this thing, or you can write epsilon here also. Epsilon upon 2h cat, that value is what? J into j plus 1, and this value is what? J minus 1. And now you can take the epsilon part as common.
Sir, each super will be there.
And h cat is also there. Very good. H cat is there. So this h cat cancel. This h cat cancel. So we have a j0. It will remain same, and we can have epsilon upon 2, and you can take j into j plus 1 common, and we have a cat j1 cat minus j minus 1 cat, isn't it? So this is all about after rotation of with epsilon on j0. So this will be your answer, and obviously this was 5 marks question. It's a wonderful question. A lot of concepts are involved. You have to understand what is this rotational matrix about y direction, and obviously you have to know what is your angular momentum algebra and how you are using j plus and j minus in process to identify what is your jy. So I think this is one of my favorite question in last 5-year examination. So everyone is comfortable?
Yes sir. Yes sir.
Yes?
सर इनफाइनाइटली का मतलब यहाँ पे
Sorry?
इनफाइनाइटली एंगल दिया हुआ है ना सर, स्मॉल एंगल.
That is epsilon.
नहीं सर, इनफाइनाइटली का मतलब क्या है?
बहुत छोटा सा रोटेशन. Infinitesimal, small.
Yes sir. Thank you sir.
Okay?
Yes sir.
Okay. So why we had taken that first order, है ना? बहुत छोटा था इसीलिए, otherwise epsilon square भी होता. Are you getting my point?
Yes sir.
Otherwise epsilon cube, sorry, epsilon square तो नहीं होता, epsilon या epsilon square भी होता है, exponential है तो epsilon square and all thing are. So we can neglect these all thing because this epsilon is very small. Okay? Epsilon tends to 0 actually if we are talking about this particular thing. ठीक है?
Yes sir.
So हमने first वाला term तो रखना ही होगा because there is not any epsilon. So epsilon is very small. So I will just go for the linear term of epsilon. Okay?
Yes sir.
ये भी हो सकता है एग्जाम में आपसे पूछे कि go up to square term of epsilon. Isn't it?
Yes sir.
हाँ,
Yes,
तो
sir.
वहां पर क्या हो जाएगा? देन यू हैव जे स्क्वायर ऑल्सो. यस,
Yes, sir.
jy square is also, and then you have to calculate jy square. What is the value of jy square on that particular thing? I will try to give question in the main examination. Okay,
Yes, sir.
ठीक है? Okay, चलो, let's try to go for next problem. This next problem is also one of my favorite one. And this question is really one of the best question. Again, you can say this was in June 2018. This is very nice problem, ultimate problem. You can just 2018, that is June, and net JRF. So net 2018. It's a wonderful problem. What is this problem? So I am just explaining you. आपके पास question है, आप इसको पढ़ोगे तो उसको फिर से सोचोगे. I am just explaining you what is this question. So initially a kit is there, or initially state of SZ for plus H cut by 2 state is there. So what is your state? 1-0 state, isn't it? So this is your 1-0 state is initially this state is there. And what you are going to do, you are just want to rotate this state about x-axis with angle theta. X-axis with angle theta is equal to 60 degree. किस डायरेक्शन में आप इसे रोटेट कर रहे हो?
About x-axis.
About x-axis with angle theta degree. So after rotation, if you are going to measure SZ, if you are going to measure SZ, what can be measurement and what is the probability? Are you getting my point?
Yes, sir.
What can be measurement and what is the probability? उसमें एक का ही measurement पूछा था, but I have just extended this problem such that I can ask what are the possible outcome and what are the probability. So look at this problem. This is not your state. आप measure किसको कर रहे हो? X के डायरेक्शन में रोटेट करने के बाद जो स्टेट मिल रहा है, यू आर मेजरिंग दैट पर्टिकुलर थिंग. यस, एंड दिस इज फॉर द स्पिन हाफ पार्टिकल. दिस इज फॉर द स्पिन हाफ पार्टिकल. एंड सो यू आर रोटेटिंग फॉर द स्पिन हाफ पार्टिकल के लिए आप इसे रोटेट कर रहे हो. ओके, नाउ यू हैव टू बी वेरी मच केयरफुल एंड जस्ट गो टू माई स्टेटस इन टूडेज. आज का मैंने स्टेटस डाला हुआ है, वन ऑफ द वेरी नाइस बुक दैट इज कोहेन तनोजी का डाला हुआ. मैं आपको शेयर भी कर दूंगा वो पेज, सो यू कैन जस्ट डू दिस थिंग इन अ वेरी नाइस वे. ठीक है, आप उसे कर भी सकते हो और डिराइव भी कर सकते हो. ओके, जस्ट ट्राई टू डू दिस थिंग. व्हाट विल बी रोटेशनल ऑपरेटर? व्हाट विल बी रोटेशनल ऑपरेटर इन अबाउट एनी यूनिट वेक्टर? अबाउट, or what will be rotational vector in any unit vector with some angle alpha? I am not taking angle theta. What I am taking? I am taking angle alpha. What is that rotational vector in a spin? So that vector is basically, if you will see, that vector is rotational vector in any unit cap, unit direct, about unit cap direction. About, जैसे यहाँ पर x cap है, वैसे any यूनिट वेक्टर के डायरेक्शन में आप उसे रोटेट कर सकते हो. विथ व्हाट एंगल? अल्फा. आई हैव डेलिबरेटली टेकिंग दिस एंगल अल्फा. आर यू टेकिंग माय पॉइंट? बहुत सारे बुक में ये एंगल थीटा ले लेते हैं, एंड देन व्हाट विल हैपन? यू विल कंफ्यूज विद द पोलर एंगल थीटा. आर यू गेटिंग माय पॉइंट?
Yes, sir.
So don't confuse with the polar angle theta. This alpha can be any arbitrary angle. Okay? And now this is defined as, again we will go for the same operator, and this operator is exponential I alpha dot S by H cut. Are you getting my point? अल्फा को भी मैंने वेक्टर के टर्म में लिखा है जानबूझ करके. Why? I will just keep this thing out of this vector and I will write in term of magnitude. So किसी भी एंगल से आप इसे रोटेट करोगे, you can just write in this form. What is S vector? H cut by 2. Isn't it?
Yes, sir.
Yes, sir.
That is what? H cut by 2. So what will happen? This value is equal to exponential I, and this value is equal to, I can write alpha, assume this is some vector alpha, dot sigma by 2, and H cut is cancel out.
Yes, sir.
Are you people happy? Now what I am going to do, I will just go for the magnitude of alpha and magnitude of alpha. So this can be written as unit vector.
Yes, sir.
Okay, and this value is exponential I some scalar quantity by 2, and this is some unit vector into dot sigma. Are you people happy? And this is the angle.
Yes.
This can be any arbitrary angle. Don't worry. This can be any arbitrary angle. So now what you can do? You can write this particular thing into a form of sine and cos. Remember last class?
Yes, sir.
कल हमने किया था, ऐसा भी एक प्रॉब्लम आ चुका है ना? So we can write this particular thing exponential, and that value is equal to I alpha by 2, and that is n cap dot sigma can be written as I cos alpha by 2, and this is minus sign. मैं minus sign छोड़ रहा हूं. So this is what? Minus sign, isn't it? So this is minus sign. So that will be what? Minus I sine alpha by 2, and what you have? N cap dot sigma. Yes?
Yes, sir.
याद है कल का
Yes, sir.
लेक्चर?
Yes, sir.
है ना?
Yes,
तो
sir.
हम लोग एक स्टेप और आगे जा रहे हैं. कल के लेक्चर से भी एक स्टेप और आगे जा रहे हैं. Are you getting my point?
Yes, sir.
Now
Yes.
look at what is this n cap? What is this n cap?
Direction of rotation.
This n cap has basically nx I cap plus ny j cap nz k cap, और nx और n cap को आप क्या लिख सकते हो? In a spherical polar coordinate, this can be written as what? Sin theta cos phi, isn't it? और क्या होगा? मैं यहां से लिख रहा हूं. What is this n cap? N cap can be written as, in a spherical polar coordinate, sin theta cos phi, sin theta, sin phi, and what is this?
Cos theta.
And cos theta. This is your n cap, and you know what is your sigma. What is your sigma? Sigma
Alpha
is
by
equal to sigma x I cap plus sigma y j cap plus sigma z k cap. Yes? Are you people happy? Now this is in the any arbitrary direction n cap. ये किसके लिए फॉर्मूला है? This is in the any arbitrary direction n cap. So suppose this n cap is in x direction. So which sigma is going to combine with this?
X.
Sigma x will be going to combine. And what is this value of n cap? 1.
Yes, sir.
Yes, sir.
Why? Because if you are talking about x-axis, just look at this, your axis. This is your x-axis, this is your y, this is your z. If I am rotating about this axis, then first I have to go into this plane, means theta is equal to pi by 2, isn't it? And phi is equal to,
Yes, sir.
and phi is equal to 0. तभी तो x-axis पर पहुंचोगे.
Yes,
Yes.
sir.
If
Yes,
I am
sir, yes, sir.
rotating about x-axis, that means theta is equal to pi by 2 and phi is equal to 0. Now look at here. This term will be gone. This term will be gone. What you have? You have only this term, and this value is 1. Isn't it?
Yes, sir.
अब देखो एग्जाम, आज सारे बुक में ये प्रॉब्लम क्रिएट किया गया है कि वहां पर इस अल्फा को थीटा लिख दिया गया. आर यू गेटिंग माय पॉइंट?
Yes, sir.
तो यहां पर आप कंफ्यूज ये हो जाते हो कि दिस थीटा एंड दिस थीटा इज सेम. आर यू गेटिंग माय पॉइंट?
Yes, sir.
ये जो आपका स्फेरिकल पोलर कोऑर्डिनेट का थीटा है, दिस थीटा इज बेसिकली इनटू एन कैप, एंड दिस अल्फा कैन बी एनी आर्बिट्रेरी एंगल. डोंट वरी. नोटेशन समझ में आ रहा है?
Yes, sir.
है ना?
Yes, sir.
So here, so in fact, when I go for this particular thing into different books. I was so much puzzled then what is happening here, that यहाँ भी theta है, अगर मैं यहाँ पर theta ले रहा हूँ 60 degree, then this thing is very weird. So actually this is not 60 degree. This alpha is 60 degree. Are you getting my point? And
Yes,
this is n cap, or you can write any unit vector in a polar coordinate in term of theta and phi, and you can identify what is your rotational axis. It may be any orbit vector, and that if it is any orbit vector, then you have to, your answer will be in term of sin, theta, phi, and in term of theta and phi, isn't it? But here we are talking about the x-axis. So what we can do, we can just go for theta is equal to pi by 2 and phi is equal to 0 degree, and then you have this particular value is 1. So this is effectively what? Sigma x. Are you getting my point?
Yes, sir.
So this rotational matrix is cos, and now this alpha is 60 degrees. So this is what? Cos 30. Yes? Minus I sin 30. And what is this particular thing? Is nothing but what? Sigma x. So this is one matrix. So this is obviously 2 cross 2 matrix. What is cos 30?
Root 3 by 2.
Obviously this is root 3 by 2. And here is also what? Root 3 by 2. And what is sigma x se multiply karega, then we have I time, what is sin 30? Half, na?
Yes, sir.
Minus I by minus plus ho jayega, na? Sorry, minus I by 2. And this will be also minus
I by 2.
I by 2. So this is my rotational matrix. Look at this question. This is huge. This is huge. And this rotational matrix is going to operate on where? 1, 0. What you will get? बताइए क्या मिलेगा? This will root 3 by 2. So you will get what? Root 3 by 2
and minus I by 2.
And minus I by 2. So what is your state psi? Your state psi is this one. Okay. So your state psi is equal to root 3 by 2 and minus I by 2. This is your state psi. And now if SZ is going to measure on this state psi, what will be measurement? You can easily write this state psi as root 3 by 2, 1, 0 minus I by 2 you can take 0, 1. If SZ is going to measure on a state psi, what will be measurement? Either h cut by 2 with probability 3 by 4, है ना? With probability 3 by 4 and minus h cut by 2 with probability 1 by 4. Sorry, ऐसा करके लिख दें. Probability of minus h cut by 4 is 1 by 4. So this is a real question. Absolutely majestic, isn't it?
Yes, sir.
है ना? It's a wonderful question. भाई एग्जाम में हो चाहे नहीं हो, but लाइफ में कभी भी आप सॉल्व करते हो, then you will feel lot of excitement, है ना? And very honestly, I can tell you, just I have started to think about this thing from night approximately 10 o'clock, and finally I resolve it at night 1 o'clock. What is actually happening here?
सर
हाँ
सर ये h कट बाय 2 सिग्मा x पे लेना सर.
क्या?
ये सर h कट बाय 2 मतलब प्रोबेबिलिटी
भाई SZ को मेजर कर रहे हैं. क्वेश्चन तो पहले ठीक से समझो. इसको रोटेट करने के बाद जो स्टेट मिला है उस पर SZ मेजर कर रहे हो. So SZ मेजर करोगे तो क्या होगा मेजरमेंट?
हाँ सर, हाँ सर.
h कट बाय 2 एंड माइनस h कट बाय 2. मैं कहाँ फंसा हुआ हूँ, ये मुझे कहाँ फंसाता है. ठीक है? Are you getting my point? So you have to be very much careful about n cap. Everything is very easy, but what is n cap? You have to be intelligently decide and don't be confused with this angle to any angle with this thing. Okay? Are you getting my point?
Yes, sir.
So I will share this copy of this thing, and this is very well explained into Cohen-Tanoji and other Cohen-Tanoji, and this is also good, very nicely explained into mathematical physics book written by Balakrishnan. This is very nicely explained there. They have also understand the complexity of notation. So he doesn't take this angle as alpha, he takes some psi, and then this will be some your spherical polar coordinate unit vector, and sigma is as usual. But in another book, it is havoc that they are taking theta here, and it will create a misunderstanding that this theta and the theta used into this n cap is really same. So they are not same, they are absolutely different thing. Okay.
Yes, sir.
Yes, sir.
चलें आगे बढ़े. तो ये दो क्वेश्चन मेरा आपके साथ शेयर करने का बहुत ज्यादा इच्छा था. इसके बाद एक और क्वेश्चन है. दिस इज ऑल्सो गुड क्वेश्चन, है ना. दिस इज ऑल्सो नाइस क्वेश्चन, एंड little bit of calculation is there. Straightforward question, but little bit of calculation is there. And actually, this question is really meant for examination. Why? Because you will stuck into calculation if you are not going to do the calculation in a very smart way. Sometime what will happen, this is very tricky, there is not any calculation. If you understand the definition, everything is cakewalk for you. But sometime you know each and everything, but what will happen, you will just stuck yourself into mess of the calculation, है ना. Calculation इतना
Yes, sir.
puzzling हो जाता है कि आप वहां पर stuck हो जाते हो. Then obviously I have to discuss this particular problem. So let's try to go for this one. चलें क्या?
Yes,
सर
sir.
सर may I ask a doubt sir?
बोलो.
सर जैसे n कैप में तो x एक्सिस को रोटेट किए phi 0 हुआ,
हाँ
बट सर थीटा पाई बाय 2 मतलब
भाई,
ये
एक्स एक्सिस पर कैसे पहुंचोगे?
phi
पहले एक्स वाई
0.
प्लेन पर पहुंचोगे तभी तो एक्स एक्सिस पे पहुंचोगे.
यस सर.
So how you will get the xy plane?
Oh, theta equals to pi by 2. Okay sir.
Huh?
Okay sir.
First you will reach the x axis, that means theta is equal to pi by 2, and then this phi will be here,
Yes sir.
है ना. So you can write this matrix for any arbitrary angle also, any theta and phi also. So that will true cross 2 matrix, isn't it?
Okay sir.
Okay, so let us go for a last one, and obviously these all 3 and 4 question is very fundamental one. Okay, so let's go for this one. So what will happen? This is in way back in NET December 2014. This is in way back NET December 2014. So actually which question I am taking for you? जो क्वेश्चन एक्चुअली जब जिस साल आया था उस साल मैक्सिमम बच्चों ने गलत किया था. आर यू गेटिंग माय पॉइंट? या फिर नहीं किया था, इन स्पाइट ऑफ उनका सिलेक्शन हुआ था. ओके
Yes, sir.
है ना. सो आई एम टेकिंग द टफेस्ट ऑफ द टफेस्ट. ओके, सो व्हाट इज दिस पर्टिकुलर वैल्यू? देयर इज अ स्टेट phi, एक तो इन्होंने उल्टा लिखा है. सो a1 psi 11 प्लस a2 psi 1 10 12 तो होगा ही नहीं, दैट इज 10 प्लस a3 psi 1 minus 1. And what is this question? This question is that this phi is eigenstate of Lx. So Lx phi is equal to nothing but h cut phi. Are you getting my point? So Lx is also 3 cross 3 matrix, isn't it? And these
Yes,
are
sir.
the eigenstate with eigenvalue h cut. So what we have to do, we have to just calculate what is value of a1, a2 and a3. इसकी वैल्यू क्या होगी ये हमें कैलकुलेट करना है. ओके, Very simple question. What you have to do? You have to operate Lx here and you will get h cut phi, है ना? So ये आप operate करोगे. But after then you have to do lot of calculation actually. So what is the idea? First operate it and we will write Lx in term of what? L plus and L minus. And then what we will do? After the operation, we will just collect the coefficient of psi 11, psi 10 and psi 1 minus 1, and then we will equate the coefficient on both sides, isn't it?
Yes, sir.
And after equating the coefficient, we have to also take care of the normalization. Otherwise नहीं हो पाएगा. What is this? A1 square plus A2 square plus A3 square is equal to 1. So एग्जाम में क्या हुआ था? बच्चों ने सारा चीज किया था, but they forget about this particular equation. Are you getting my point?
Yes, sir.
ये दिमाग में नहीं आ रहा था कि आप तीसरा इक्वेशन कहां से लाएं जिससे कि सीजे निकल करके आए. So this is one of the very fundamental thing that you have to remember. This is so trivial in the quantum mechanics that we forget actually this one. समझ में आ रहा है?
Yes, sir.
है ना? So this is one of the very fundamental thing. So let us try to go for first L plus, obviously what is my Lx? My Lx is equal to L plus L minus by 2, isn't it? So first we have to calculate L plus phi. What will be L plus phi? This term will be 0. You have A2 root 2 h cat psi 11, isn't it?
Yes,
And
sir.
plus A3 root 2 h cat, that is psi 10. So this is my first thing. And second, we have to also calculate L minus phi, and that value is A1 root 2 h cat psi 10 plus A2 root 2 h cat psi 1 minus 1, and this third term will be 0. So obviously we have calculated Lx, but we have to write this thing such that we can take the coefficient of 1 1, 1 0 and 1 minus 1 separately. है ना? And obviously 1 by 2 is always there. 1 by 2 is always. So what we will do? We will just take L plus L minus phi is equal to nothing but 2h cat phi. लिख सकते हैं ना? This 2
Yes,
will
sir.
be in this side. लिख सकते हैं ऐसा?
Yes, sir.
है ना? So let's try to go for just take the coefficient of psi 11. There is only one term, na? So that value is root 2 h cat A2 psi 11. And about psi 10, you have two coefficient. What is this particular thing? Root 2 h cat.
A1
And
plus
what you
A2.
have? You have A1 plus A3 psi 10 plus next one is what? A2 root 2 h cat psi 1 minus 1, and this is equal to 2 h cat psi 2 h cat A1 psi 11 plus 2 h cat A2 psi 10 plus 2 h cat A3 psi 1 minus 1. So what we will do? What we will do? We will
Yes, sir.
just equate the coefficient on both sides.
Yes, sir.
है ना? So what is the first coefficient? We are just going to equate. We are just going to equate the psi 11 to psi 11. What you will get? You will get A2 is equal to A1 by root 2, isn't it?
Yes, sir.
And third one we are also going to, then A2 is equal to A3 by root 2. So from here, A1 is equal to A3, isn't it? ये पहला हमें मिल गया, है ना?
Yes,
So
sir.
A1 is equal to A3 we can get from there. Yes. And what will be next one? Next one have A1 plus A3 is equal to A2 by root 2. Isn't it? A1 plus A3 is equal to A2 by root 2. So now we can easily write in A1 as √2 time A2, A3 √2 time A2, you can easily get this particular value. आ जाएगा ना?
Yes, sir.
तो एक
सर
एक
ये शायद
सॉरी
सर उल्टा तो नहीं लिखा सर?
क्या लिखा हूं बताओ?
सर ये A1 सर A1 इक्वल टू A2 बाय √2
क्या लिखा हूं? कुछ गलत लिखा हूं क्या?
आ रहा है सर।
तो वो
Just check it.
√2
सर वो 1/2
√2 ऊपर आएगा।
सर ये 1/2 होगा ना सर ऊपर?
हाँ सॉरी सॉरी
वो
That is what?
1/2 नहीं आया
एक मिनट मैं क्या कर रहा हूँ? √2 A1 सॉरी
sir.
दिस विल व्हाट √2 A1 है ना? √2 A1 and this value is also √2 A3. Okay, and this value is also
A1 plus A3
√2
√2 A2.
A2. Now, okay, yes. So you can solve this particular thing and you can use this one. You can easily calculate all this value, है ना? यहाँ से आप कैलकुलेट करोगे A2 की वैल्यू मिल जाएगी. इन तीनों से भी कर सकते हैं. And you can take this one and
Yes,
you
sir.
can have this particular value. So just you can calculate with yourself that you will get A1 is equal to A3 is equal to half
1/2
and A2 is equal to 1 by √2. Okay, just you can calculate it and you will find this particular problem. ठीक है ये?
Yes, sir.
है ना? So these are from my side of some good questions. Okay, and now you can try with yourself. अब आप इसको try करो सारे problems को. Just enjoy all this learning, है ना? So from tomorrow we will just go for a radial wave function. ठीक है? So कल हम radial wave function में किस तरह से mathematics और quantum mechanics को introduce करेंगे. Obviously we have done lot of theta and phi, and now we will go for what? Radial part. Okay? So in radial
Yes, sir.
part, then hydrogen atom. So third part will over. First part is the postulate. Second part is the one-dimensional. Third part is all about degeneracy and in the spherical polar coordinate, more than 1 degree of freedom. Okay, and then we will go for the final part. That is what? Approximation method. ठीक है?
Yes, sir.
Okay.
Yes, sir.
So please revise mode में आप चले आइए because exam आ रहा है. And don't think आगे वाले टॉपिक के बारे में भी जो होता जा रहा है उसको फटाफट रिवाइज करते जाओ, है ना? ओके
Yes, sir.
तो अनफॉर्चुनेटली